Good evening, dear students. Once again, welcome back to surveying. So, based on your feedback, today for the first half an hour, I would like to take up a session on skills in surveying, because I also got to know that the scale topic is very important for the examination point of view. So, I prepared few slides for scales in surveying. So, let me start with the scale. Okay, you can able to see the slide. So why scales in civil engineering or in surveying? Why scale is necessary? So we need to ask actually why this scale is required for civil engineers, and also what is the purpose of the scale in civil engineering. So if you look at actually my slide, the area that is surveyed is vast. So it's not a small area, it's a big area. If you'd like to prepare plan or map, you need to survey a large area, and plans are made to some scale, right? You need to create a scale in order to prepare plans. Okay. So what is that scale is all about? I am talking about only the scale. What is that scale? What is the meaning of scale? It is actually the fixed ratio. So scale is a fixed ratio between what? Between every distance. Please look at actually the underlined terminologies. Every distance on the plan bears with corresponding distance on the ground. So it is distance on the plan divided by distance on the ground. So it is the ratio, a fixed ratio. For example, if you take any map or a plan, it is a fixed ratio between distance on the plan, corresponding distance on the ground. Okay. So what are the methods of representing scales? So how scales can be represented in our civil engineering or in rather surveying? So the first one is, it is being highlighted here, engineer scale. What is this engineer scale? So engineer scale is nothing but 1 centimeter on the plan represents some meters on the ground. So here we are going to represent the scale in terms of centimeter or meter. So you can look at actually the example such as 1 centimeter is equal to 10 meter, or 1 centimeter is 50 meter. So this type of scale is called engineer scale. So that means to say we are going to represent the scale using centimeter and meter. Okay. So that is why how to define engineer scale. 1 centimeter on the plan represents some meters on the ground. Okay. What is the second method? Here, instead of centimeter and meters, we consider unit. 1 unit length on the plan represents some number of same units of length on the ground. So same unit. Please do remember, 1 unit length of the plan represent some number of same units of length on the ground, such as, look at here, 1 by 100, 1 by 1000, or you can say 1 by 25,000. If you consider actually Karnataka map, it is 1 by 50,000. India map 1 by 2,50,000. Like that, actually, it is 1 unit of length on the plan represent some number of same units of length on the ground. So this is nothing but ratio of map distance to the corresponding ground distance. Map distance divided by ground distance, and is independent. Please do remember, it is independent of measurement, independent of units of measurement. We are not going to use any centimeter or meter. It is only a ratio, and this is called as representative fraction. So please look at any plan or a map. If it is there in your home, okay, instead of scale, they represent this as representative fraction. This is a fraction, 1 by 100, 1 by 1000, 1 by 25,000, okay, 1 by 50,000, 1 by 2,50,000. So it is called as representative fraction, or also called as RF. Okay, so we got to know about engineer scale and representative fraction. Once again, I repeat, in the engineer scale, we are going to mention the centimeter on the plan and meter on the ground. Whereas here, it is only a unit. So it is independent of units of measurements. So we are not going to mention any centimeter or meter in case of representative fraction. So little bit information about representative fraction. So representative fraction can be very easily found for a given engineer scale. Okay. If somebody gives me engineer scale, is it possible for me to find representative fraction? Okay. My question is, if somebody gives me engineer scale, is it possible to calculate representative fraction? Yes, my dear friends, it is possible to calculate representative fraction using engineer scale. So once again, please do remember this important point, that is representative fraction is equal to map distance divided by ground distance, MD by GD. Okay, please do remember, representative fraction is equal to MD by GD. So MD is nothing but map distance, GD is nothing but ground distance. This is called as RF, representative fraction. Okay. In order to understand this, let me take up one example. So in order to start with, I would like to take a simple example. If the scale is 1 centimeter is equal to 50 meter, 1 centimeter is equal to 50 meter. What is the representative fraction for this engineer scale? Okay, everybody knows actually this is engineer scale now, right? What is the RF value for this engineer scale? So RF value can be easily calculated. Map distance, okay, map distance 1 centimeter divided by ground distance, it is 50 meter. Since in the representative fraction we already defined that here we will not consider units of measurement like centimeter and meter. We convert all the units of measurements into one single unit of measurement, right? So since actually in the numerator centimeter is there, I am going to convert this 50 meter, right? 50 meter is there now, that I am going to convert into centimeter. So how to convert meter into centimeter? Everybody knows the conversion. 50 multiplied by 100. So 50 multiplied by 100 is nothing but 5,000. So it becomes 1 by 5,000. So I need not have to write centimeter because the numerator and the denominator cancel out each other. So it becomes only a fraction. So that is why this is called as a representative fraction, my dear students. Okay. So if somebody gives us actually the engineer scale, how to convert into representative fraction, we need to actually take the same units in the numerator as well as in the denominator. Okay, here in the numerator centimeter is there, in the denominator meter is there. So I'm going to keep actually the numerator as centimeter, denominator I will convert meter into centimeter, so I can easily convert the engineer scale into a representative fraction, right? Now there is another scale. So we got to know about engineer scale, representative fraction. But if you look at the maps, we can also find what is called as graphical scale or diagonal scale. When I was a student, we used to prepare all our extensive survey camp drawings, okay, using diagonal scale. It is mandatory to create actually the drawings using diagonal scale. Why diagonal scale? And what is first of all diagonal scale? So let us understand first of all the diagonal scale and why diagonal scale in civil engineering. So an alternative way of representing the scale is to draw on a plan a graphical scale. Okay, a graphical scale. What is this graphical scale? Graphical scale are also called as diagonal scale is a line subdivided into planned distance corresponding to convenient units of length on the ground. So it is subdivided. Okay, planned distance is subdivided into 10 pieces so that conveniently we can make use of that for the units of length on the ground. So why this diagonal scale in surveying or civil engineering? You know that if the plan or map is to be used after few years, the numerical scales may not give accurate results because the sheet of paper shrinks. Any material including paper, depending on the temperature variation, it shrinks. So since actually the paper shrinks, this graphical scale, if it is also drawn, it will shrink proportionately and the distances can be found accurately. So what I'm going to do is I'm going to use the graphical scale which is already written on the map, and along with the sheet the graphical scale also shrink so that these survey maps are always drawn with diagonal scale. Why diagonal scale? Because if some question is there actually on the diagonal scale, we need to understand why diagonal scale, because the paper shrinks after few years. Along with the paper, if the diagonal scale is also drawn on the paper, then diagonal scale also shrinks and we can make use of the diagonal scale for easy measurement on the survey maps. So there is a new terminology arrives. What is that? Shrunk scale. What is this shrunk scale? Before understanding the shrunk scale, we need to understand what is called as shrinkage ratio or shrinkage factor. Shrinkage ratio or shrinkage factor. So already the name is shrinkage ratio. So it must be a ratio between two factors. So it is the ratio, look at here, it is the ratio of the shrunk length to the actual length. Okay, please do remember, shrunk length to the actual length or shrunk scale to the original scale. Please, you need to remember this. Okay, once again I repeat, shrinkage ratio or shrinkage factor is the ratio of the shrunk length to the actual length or shrunk scale to the original scale. So shrunk scale can be written as shrinkage factor multiplied by original scale. Okay, so how I can write actually the shrinkage factor then? So shrinkage factor or shrinkage ratio is shrunk length divided by original length. Shrunk length divided by original length or shrunk scale divided by original scale. Okay, this is important. 3-star rating for this. Okay, you need to remember this because when I went through the question papers, usually if there is any question on the scale, the problem will be asked actually based on the shrinkage ratio. Okay, I will take a few problems based on this. And one example also I would like to give in order to understand whatever that is written here. So if the shrinkage factor is equal to 15 by 16, shrinkage factor is equal to 15 by 16, and if the original scale is 1 by 1500, then what is shrunk scale? Okay, shrunk scale is equal to, already we got to know actually the equation for shrunk scale, shrinkage factor. So what is the value of shrinkage factor? 15 by 16. Okay, that I have written here. 15 by 16 multiply by the original scale. What is the original scale? 1 by 1500. So if you substitute these two in the equation, then you will get 1 by 1600. This is shrunk scale. This is the simplest of all the problems. Okay, sometimes you may feel actually this is so simple. This is how actually the question, the numerical problems will arrive in the examination. So we need to know the basics of the scales. What is shrunk scale? What is shrinkage factor or shrinkage ratio? So that is why I written actually 3-star rating for this. Now the problem. A line of 5 meters on the original map. A line of 5 meters on the original map is shrunk to 4.6 meters. 5 meters on the original map got shrunk to 4.6 meters. Calculate shrunk scale. If the original scale of the map was 1 centimeter is equal to 80 meters. 1 centimeter is equal to 80 meters. So how to go by? So we need to remember that equation which I said actually earlier, 3-star rating equation. If you can able to recollect that equation, You can easily solve this problem. Okay. So I made it easy for you in the solution. Okay. Just a representation of the problem in a sketch. So this is the original line on map. Original line on map. It is actually 5 meter. Right? Shrunk line on map. Due to shrinkage actually. Okay. Now after some years, the same AB length is showing 4.6 meter. Got it? So this is not required actually. You need not have to write all this diagram. Only for the understanding, okay, I created this diagram. So I can write that length of the original line AB is 5 meter. Length of the shrunk line is 4.6 meter. Okay. So original scale of the map, it is given as 1 centimeter by 80 meter. It is there actually the problem. Original scale of the map is 1 centimeter by 80 meter. So immediately what I should do, I should actually convert this into RF, right? This is engineer scale. This I need to convert into RF. This is engineer scale, right? I need to convert into RF in order to go further. So how to convert engineer scale into RF? So 1 centimeter, I keep it as 1. So 80 meter, I will convert into centimeter. It is 8,000. Okay. So 1 by 8,000 is the RF value for the original scale. So we got to know that shrinkage ratio is equal to shrunk scale or shrunk length, rather shrunk length divided by original length, also shrunk scale divided by original scale. Okay, please do remember this. Once again, I repeat, shrinkage ratio is equal to shrunk length divided by original length, also shrunk scale divided by original scale. Okay, afterwards, what I'm going to do is, I will take this part of the equation. Okay, so shrunk length divided by original length. It's given in the problem. What was the shrunk length? 4.6 meter, right? What was the original length? 5 meter. So 4.6 by 5. Then the shrunk scale I need to calculate. What is the original scale? Original scale is just now calculated 1 by 8,000. So here 1 is unknown, whereas other 3 are known. So by cross multiplication, I can easily calculate shrunk scale, right? So it becomes 1 by 8695. Please use the calculator and tell me the value, or otherwise you can check whether this value is correct or not. 4.6 divided by 5 multiplied by 1 by 8,000, you will get 1 by 8695. So what I am going to do is, I am going to convert this RF value, this is RF, right, into engineer scale. So 1 centimeter, 8695 is converted into meter. So it is 86.95 meter. So I'm going to keep actually the shrunk scale of the map in terms of 1 centimeter by 86.95 meter. Okay. Why I'm keeping this actually, I can leave it here 1 by 8695. I am converting this into engineer scale, since actually the original scale is in terms of engineer scale. So that is why I am also converting shrunk scale into engineer scale. So 1 centimeter is equal to 8695. So if it is actually MCQ, you need to choose accordingly. So they may give actually in terms of engineer scale, or they may give in terms of representative fraction. So if you know how to calculate the representative fraction from engineer scale or engineer scale from the representative fraction, you can able to do it without any problem. But only thing is, you need to remember this. Once again, I repeat, shrinkage factor or shrinkage ratio is equal to shrunk length divided by original length or shrunk scale divided by original scale. Okay. So this is one of the problem that I selected in order to explain. Another problem is there. It is simple problem. The scale of a map is represented by representative fraction as 1:4,000. So it is RF value. Okay, I think you are all familiar with this now. Representative fraction as 1:4,000. Since there is no centimeter or meter is given, so it is obviously a representative fraction. The distance between 2 points A and B in the map is 10 centimeter. So there are 2 points on the map. The distance is measured. It is equal to 10 centimeter. Then the question is, the distance of AB on the ground in terms of kilometer. So they are asking us to calculate in terms of kilometer. So please try this problem on your own and get me the right answer. So please try, and you can put actually the answer in the meeting chart. And I said actually, whenever I am solving the problem, we need to keep a notebook and a pen, because our class should be interactive. If the class is not interactive, then you will forget whatever that is being discussed now. So if you can able to solve the problem now itself, so that you will get confidence. Yes, I got to know about actually the representative fraction as well as the engineer scale. Okay, I believe that you are all trying this problem on your own. Let me show the solution. So it's very simple. So what is representative fraction, my dear students? It is map distance. Okay. It is map distance divided by ground distance. MD, easy to remember. MD divided by GD. Okay. So given that in the problem, the representative fraction, it's given in the problem, 1/4,000. Okay. Map distance is also given in the problem, 10 centimeter. Right. So map distance is given, representative fraction is given. So only thing is we need to substitute. So RF value is 1/4,000. Map distance is 10 centimeter. See here, I am writing the unit 10 centimeter divided by ground distance. So by cross multiplication, what happens? Cross multiplication means GD goes to the numerator here, 4,000 goes to the numerator. Therefore, ground distance is equal to 40,000. That is 4,000 multiplied by 10, 40,000 centimeter. But what is there in the problem? They are asking us to calculate the ground distance in terms of kilometer. So you should not forget to convert the centimeter into kilometer. So how to convert centimeter into kilometer? See, 1 meter is equal to 100 centimeter. Okay. So if I remove 2 zeros, it becomes meter. So 400 meter is nothing but 0.4 kilometer. I think you're all familiar with this because you're the undergraduates in civil engineering. I think you're all familiar with these simple conversions. Okay, from kilometer to centimeter or centimeter to kilometer. I believe that you can able to understand very easily. So therefore, the distance AB on the ground is 0.4 kilometers. So you need to choose the right option. This is the problem that will appear in the examination for 2 marks. Okay, so that is why I chose meticulously the examples as well as the numerical problems, so that you can able to understand the scales easily. Okay, I think this is the end of the scale. Yes.